Hello, my dear students. How are you all? I am fine. I am Khandakar Fazle Rabbi, lecturer, Department of Chemistry, Milestone College, Uttara. My dear students, during this pandemic situation, welcome you all to our online chemistry class. Today, we discuss about some important topics from chemistry first paper, chapter 2, qualitative chemistry. My dear students, now we discuss about the topics crystallization. The process by which an impure compound is converted to its crystals is called crystallization. An organic compound contaminated with impurities is dissolved in a suitable solvent such that the desired substance remains soluble in the solvent and the impurities remain insoluble. After filtration, the filtrate is heated to a higher temperature and later cooled slowly to lower temperature. The desired substance crystallizes out. Crystallization is a widely used method for the purification of solid substances. The solubility of a solid solute in a particular solvent increases with increasing temperature. So, whenever a warm saturated solution is cooled, the solubility decreases and the solute starts to crystallize out from the solution. Slow cooling usually results in the formation of large crystals. Soluble impurities are generally present as small amount in a solution. Before cooling, any kind of insoluble impurities must have to be removed by filtration. It is very important to select a suitable solvent for crystallization process because success of crystallization depends on the selection of solvent. Generally, solvent of a particular nature dissolves that type of solute like dissolves like. That means non-polar solvent such as hexane, carbon tetrachloride, chloroform, toluene dissolves non-polar type of solute, and polar solvent such as ethyl acetate, ethanol, water is suitable for dissolution of polar solute. Often, organic crystals are observed to be pale because of the presence of small amount of impurities. In such case, before crystallization, the solution is heated with small amount of activated carbon. Finally, the crystals obtained are separated through filtration. Often, the crystals are separated from the mother solution through a Buckner funnel at reduced pressure by using water pump. The crystals are washed several times with cold solvent and dried on the filter paper. Later on, the purity is determined by measuring the melting point. My dear students, now what is fractional crystallization? When the solubility of two substances in any solvent is not so much different from one another, then the two compounds can be separated by fractional crystallization, involving a series of repeated crystallizations. For example, when a solution containing two substances A and B is subjected to crystallization, the slightly less soluble substance, if that is A, containing a small amount of the other substance B, crystallizes out first. The mother liquor, when subjected to crystallization, gives crystals of B containing a small amount of A. Further, recrystallization of B affords pure sample of B. So, my dear students, according to our discussion, we can say that a selective crystallization of one substance from a solution containing two or more substances is called fractional crystallization. Water, alcohol, ethane, etc. may be used in this process as solvents. Sugar is purified in this process in sugar industry. My dear students, now we discuss about common ion effect. Common ion effect refers to the decrease in solubility of an ionic precipitate by the addition to the solution of a soluble compound with an ion in common with the precipitate. This behavior is a consequence of Le Chatelier principle for the equilibrium reaction of the ionic dissociation. The effect is commonly seen as an effect on the solubility of salts and other electrolytes. Adding an additional amount of one of the ions of the salt generally leads to increased precipitation of the salt, which reduced the concentration of both ions of the salt until the solubility equilibrium is reached. The effect is based on the fact that both the original salt and the other added chemical have one ion common with each other. My dear students, hydrogen sulfide is a weak electrolyte. It is weakly ionized in its aqueous solution. There exists an equilibrium between unionized molecules and the ions in an aqueous medium. By applying the law of mass action, we have Ka equal to concentration of hydrogen ion square into concentration of sulfide ion divided by concentration of hydrogen sulfide. To the above solution of hydrogen sulfide, if we add hydrochloric acid, then it ionizes completely as hydrogen ion and chloride ion. This makes a common ion and creates a common ion effect. Due to the increase in concentration of hydrogen ion, the equilibrium of dissociation of hydrogen sulfide shifts to the left and keeps the value of Ka constant. Thus, the ionization of hydrogen sulfide is decreased. The concentration of unionized hydrogen sulfide is increased. As a result, the concentration of sulfide ion is decreased. This is common ion effect. My dear students, now we discuss about distillation and fractional distillation. For separation and purification of organic compounds, several physical methods are applied to separate and purify the desired product from reaction mixture. Distillation methods are used for the purification of desired compound from liquid or liquid solid solution. Now, the definition of distillation: the process by which a liquid is vaporized by heating and the vapor is cooled to pure liquid is called distillation. The operation of distillation is employed for the purification of liquids from non-volatile impurities. The impure liquid is boiled in a flask and vapors so formed are collected and condensed to give back the pure liquid in another vessel. The non-volatile impurities are left behind in the flask. Now we discuss about simple distillation. This technique is used for separating liquids having boiling points differing by 10 to 12 degrees. The liquid having lower boiling point distills over fast, and the other liquid component is left behind. In this process, vaporization and condensation occurs side by side. Now, the process of simple distillation. The impure liquid or a mixture of two liquids is taken in a distillation flask fitted with a thermometer and condenser. The distillation flask is heated on a sand bath. The more volatile liquid boils fast and its vapors leave the flask from the outlet. These vapors then pass through the condenser and get condensed to liquid. The condensed liquid called distillate. The condensed liquid is collected in a receiver. The less volatile liquid is left behind in the distillation flask. To avoid bumping the liquid, a few glass beads or porcelain pieces are placed in the distillation flask. My dear students, now we discuss about fractional distillation. A mixture of two or more volatile liquids can be separated by fractional distillation when their boiling points differ by more than 40 degrees centigrade. The operation can be carried with help of simple distillation apparatus. The more volatile liquid passes over fast and is collected in a receiver. When the temperature begins to rise for the second time, the first receiver is disconnected. A new receiver is attached as soon as the temperature becomes constant once again. Thus, the distillate is collected in fractions and the process is termed fractional distillation. The vapors from the boiling liquid mixture are made to pass through a glass column packed with glass beads or through a specially designed column. The vapors of the low volatile component get condensed in this column and return to the distillation flask, while the vapors of the more volatile component leave the column from the exit near the top. These vapors enter the condenser and get condensed and collected in a receiver. The less volatile liquid and the liquid having higher boiling point is left behind the distillation flux. One typical example for the application of this technique on commercial scale is the fractional distillation of crude petroleum to get different fractions such as gasoline, kerosene, lubricating oil, etc. My dear students, now I discuss about solvent extraction. This process is used to isolate or separate a solid or liquid from a mixture of two or more substances. The process by which the substance of a mixture dissolved in a solvent can be isolated by dissolving it into another suitable solvent is called solvent extraction. The general principle is that polar compounds are soluble in polar solvents. Nonpolar compounds are soluble in nonpolar solvents. Organic compounds, being covalent compound, are more soluble in organic compound solution. Organic compound is dissolved in an organic solvent which is immiscible with water. When an organic substance is present as solution in water, it can be recovered from the solution by the following steps. First step, the aqueous solution is shaken with an immiscible organic solvent in which solute is more soluble. And step 2, the solvent layer separated by means of separating funnel. The applications of solvent extraction. Extraction of different alkaloids, terpenes, steroids from plant leaves, barks and fruits. Extraction of oils from coconut, soybean, palm and crop seeds. Extraction of red dyes from paper powder. My dear students, now we discuss about chromatography. Chromatography is employed for identification, purification or separation of constituents of a mixture present in very small amounts. The name chromatography comes from two Greek words, chroma meaning color, graph means graph or picture, overall meaning color picture. This name shows the origin of the technique in the separation and analysis of colored dyes and plant pigments. Attempts have been made to define chromatography in different ways. H.G. Cassidy defines chromatography is primarily a separation process which is used for separation of essential molecular mixtures. Another definition is chromatography is a separation process involving two phases, one stationary and the other one is mobile phase. Chromatography is classified into three types: adsorption chromatography, partition chromatography and ionic change chromatography. section for adsorption chromatography is column chromatography and thin layered chromatography. Partition chromatography is two types: paper chromatography and gas chromatography. And for ionic chain chromatography, we get two types: chromatography system, cation chromatography and anion chromatography. The uses of chromatography: purification and refining of organic compounds, comparison of organic compounds with a known compound, identification of an unknown organic compound, detection of presence or absence of an organic compound in a given sample, monitoring chemical reactions, quality control of industrially used chemicals, measurement of quantity of certain substances present in a given sample, identification of pollutants responsible for environmental pollution, detection of ratio of any isomers produced in a chemical reaction, separation of organic compounds belonging to the same homologous series. My dear students, now the principle of chromatography. The method is based on the differential adsorption of the various components of a mixture on a suitable adsorbent. Suitable adsorbents are magnesium oxide, alumina, cellulose paper, silica gel, etc. The adsorbent is termed as fixed or stationary phase, and the liquid in which the substance is dissolved is termed as mobile or moving phase. Depending upon the nature of the two phases, there are various types of chromatography techniques. Broadly, chromatography is divided into adsorption chromatography and partition chromatography. Now we discuss about column chromatography. The column is a glass tube or burette packed with an adsorbent material. Here, the suitable adsorbent like alumina, silica gel is packed in a column, and this constitutes the stationary phase. The solid adsorbent is made into a slurry with selected solvents poured into the column and allowed to settle. Then the solution of the mixture to be analyzed is kept on the top of the column so that the compound can be adsorbed on the column. The second solvent, called eluent, is passed through the column. The eluent carries the solutes. Non-polar component eluents first allowed by the polar ones. The eluents are collected in a flask, and evaporation of the solvent gives separated solutes. This is adsorption chromatography. It is based on the differential adsorption of the constituents of a mixture, and it is simplest chromatographic method. The mixture to be separated is taken in a suitable solvent, and the solution is poured on the top of the column of the adsorbent. The components are then eluted out by a suitable solvent, which acts as mobile phase, or solvent mixture. The other adsorbent which can be used for this purpose are magnesium oxide, silica gel. Now we discuss about paper chromatography. Paper chromatography is a type of partition chromatography in which the adsorbent column is a paper strip. It is special type of chromatography paper which contains water trapped in it. This acts as a stationary phase. In this method, a line is drawn by a pencil on the chromatography paper parallel to 1/8. Then a drop of the solution of the mixture is applied as a small spot on the line. The spot is dried by blowing hot air over it from a dryer. After drying, the paper is kept in a closed chamber and aids for the filter paper is dipped into a suitable solvent for proper development. The solvent to be used as developer depends upon the nature of the components of the mixture. The solvent rises up the paper by capillary action and follows over the spot. The mixture gets separated into its components, which also move upward to different extents. Because of their different speeds of movement, the paper selectively retains different compounds according to their differing partition in two colored compounds, which are visible at differing highlights from the position of initial spot on the chromatogram. The spot of the separated colorless compounds may be observed either under ultraviolet light or by the use of an appropriate spray reagent as discussed in their layer chromatography. Light. Use of paper chromatography. Identification of mixture of sugar, amino acids, lipids and nucleic acids. Now, what is retardation factor value? The position of the separated components such as X or Y can be identified by chemical or physical process. The distance traveled by the separated components X and Y is expressed by the value of RF, that is retardation factor value, where RF equal to distance traveled by the solute divided by distance traveled by the solvent. As RF is ratio of distance, so it has no unit. The value of RF is in the range of 1 to